of Achievers. It's where all the developers live and work every day. And we encourage all our developers to reach out to the community, to give back to the community. We utilize a lot of open source software. We utilize the community extensively as we grew. And so we want to give back. So we have these events, and we encourage our developers to come up with ideas. So when Brian said, hey, I'd like to host an event with Full Stack Toronto, I said, sure, that sounds great. And then he said, hey, I'd like to have some beer and pizza. I'm like, who has a meetup without beer and pizza? So, well, you're going the wrong meetup. Come to the Achievers Tech events. Speaking of Achievers Tech events, we are having an Achievers Tech event here on January 20th. It's a panel, and it'll be called How to Not Disrupt Your Users. At Achievers, we pride ourselves on our uptime. If you remove one tiny little hiccup, we would have 100% uptime. If you add the tiny little hiccup, we still are over 99.95% up. So we would like to share how we do it, how we manage to keep our uptime numbers pretty impressive, but yet still manage to deploy code on a consistent basis. So if you're interested, please join us on January 20th. Here, you can go to our Meetup page and sign up so that we know how much food to have for that night. So one of the things I was asked to do, the cost is exactly zero. I get, like, you can't, yeah, you can try to argue, then I have to be paying you, and that just seems, then you'd be working for me. So I don't know, maybe that might work too. It can really go either way here. I was asked to actually talk a little bit about Achievers, but I'm not. You guys are all tech guys. I don't think you really want to hear too much about what we do and who we are. So I'm actually going to give you a little bit about the technology we use at Achievers. So not really give you a company pitch, but just give you a sense of what we do here. So Achievers is an online platform. It's an online HR platform. Our corporate motto is change the way the world works. And we're pretty proud of what we've done. When I joined 5 years ago, there were 5 people in dev. I was employee 20-something. Almost 6 years later, we have about 60 people in my department, and we have 250 people. We handle somewhere around 50 requests per second. We do pretty close to 10 million page views a month. We have data centers in Toronto, real-time replication over to San Francisco. We have a pretty sophisticated architecture and to ensure our uptime, ensure our customers get satisfaction. And when we look for developers, we look for full stack developers. We want people that understand the front end, that understand the back end, that understand when we talk about no single points of failure, that understand what it means to fail over to another data center. All of that stuff is what we do day to day. We are hiring, so obviously here comes the 30-second, please ask us if you are interested speech. If you are interested in finding out more about Achievers, please find people that have the I love Achievers, I'm an Achiever, or something, a player, change the button on me, and ask them learn more about Achievers. We also have 2 lovely ladies from Robert Halford. Don't talk to them. They're trying to recruit you. Evil, bad. Yeah. So feel free to talk to them also if you're interested. But please reach out to Achievers to learn more about what we do. We believe that if we're not number 1, we're probably number 2 or number 3 in terms of size and scale in the GTA. So if you like working on large problems, if you like working with other really smart people, if you really enjoy pushing the envelope of technology, then Achievers might be interested in you, and you might be interested in Achievers. If nothing else, enjoy the evening. Come and join us the next Tech Talk. And you never know. You may want to come here at some point in the future. We'll convince you. I'm not worried about it. Have a great night. Thanks very much. Thanks. Do you want the Madonna mic? 'Cause it actually looks awesome. Like it does look really good. Yeah, it was. I would have gone with the mic. It's pretty cool.
Oh, that's how it works. Apparently not. This is like really cool. But I'm having trouble putting the thing on my back. Probably. Hello. Whoa, weird. I feel like a space station. I'm giant and I've got this little antenna. All right, so I'm James. I am the executive director of Full Stack Toronto. We are the lovely people that put on these events with the awesome help of people like Achievers, so thank you guys for doing that. They also provided you with all of this lovely beer and pizza and snacks, a little bit of feedback. I want to turn it down just a little bit. Ta-da, there we go. You should all still be able to hear me and online could hear me. I want to tell you about something awesome coming in 2016, our conference again. I know a lot of people have thought I was crazy, the fact that the website's up already for 2016, but you wouldn't believe how much stuff goes into organizing these things. We need your support, both if you want to register, which you can't actually do yet, despite the website saying you can, but also for sponsors. So if you work for a company that's looking to dish out some money this year, I want it. More specifically, the nonprofit wants it. So we are a nonprofit. Everything we do goes back to making this community better, both web professionals and web developers. We focus on front-end, back-end, DevOps, full stack, UX, project, product, content, and Internet of Things. There's 10-ish, if anybody was counting. So this year we're expanding the conference. It's going to be on a Monday, Tuesday. People said that's cool. You're going to get the 2 days filled with networking sessions, of course the mobile app for everything, video recordings of all the sessions. If you want to take a look after the event at all of the recordings from last year, you can find them on the homepage right here. It'll even bounce at you when you load the page. It's kind of cool. You know, completely useless, but it's there. Just to get your attention. So you can look through all the videos from last year, learn a lot of stuff. We go with a different type of model. We make sure that whoever is speaking has a breadth of knowledge in what it is that you're doing, and then goes into something in sort of a pillar, a deep dive into something. That's usually a code display or some sort of case study or some research stuff. So that's pretty cool. That's Full Stack Toronto. I'm also one of your speakers tonight. Hey! Let me switch over to that. Well, bye-bye, Spotify. So what I'm going to talk to you about is front-end performance quick wins. So this is stuff that you can do hopefully relatively easy in your environment. If it's difficult, we've got some bigger problems we need to tackle. But hopefully relatively easy for you to do just to improve the performance of your website. So, like I said, I'm James. In addition to being the executive director of Full Stack Toronto, I also lead up the performance team at Loblaw Digital. I also have my coworker Sean here somewhere. Hey, Sean in the back, if you want to learn more about Loblaw Digital. We do all of the e-commerce side of Loblaw Companies Limited. So we tackle Joe Fresh, Beauty Boutique, Click and Collect for Loblaw's Click and Collect for Superstore, and some cool, awesome stuff coming in the future. So if you're looking for a job there, you can also talk to us too. Also talk to me about volunteering at Full Stack. So let's dive deep into this stuff. Some stats. So the average online shopper, I obviously come from a very e-commerce background, so the stats are e-commerce related. Average online shopper expects the site to load in 2 seconds. Who thinks that's like really fast? And who thinks that's really slow? Awesome. You guys don't even need this talk. You already think that's slow. Or fast? I don't know. So poor performing mobile sites rarely see repeat visitors. That's like detrimental to your sales. Someone like wants to look you up and like your website is like not performing on mobile, they're gone. You've lost them entirely. And e-commerce in itself online is expected to be becoming a $1 trillion business by 2020. That's a stat from last year's Nielsen report. 2014's Nielsen report. So I don't even know what the 2015 one says yet because I haven't found it. So in order to understand what we can do on the performance side of things, we need to understand how the browser works. So once you've gone and typed in yourself into the browser, and you've hit the page, the server is going to serve up to the browser the HTML, and then from there, it's going to create the document object model. Most people are familiar with this: jQuery, DOM ready, do stuff, manipulate the DOM, get element by ID. Everyone's pretty much familiar with what the DOM is. That's about the first thing that happens. So on DOM ready can actually happen almost at any time. Then your styles are loaded, and then they're parsed, and that together creates the CSS object model. This is something that people aren't as familiar with. They don't understand that there actually is another object model involved with painting your browser. So on top of the DOM and then the CSS OM, a rendering tree is created. So this is where it kind of takes in the hierarchy of the HTML you've done. And then that set of objects is set to be rendered on your page. Once it's got what all of the objects are to be rendered, combines that with the CSS OM, gets the coordinates calculated, and that's called doing the layout process of the browser. And then using a flow method, which only requires one pass, it goes and lays out all of those elements. So it's calculated where everything's going to go, and then just kind of just like da-da-da, just one after the other, keeps going down. However, if you've thrown a table in there, it's got to do it again, and again, and again, and as many times as you have columns in your table. So after all that has happened, that's sort of just the layout. Then you'll actually start to see it. That's when it's called painting. And that's when we show in the content to the user. This is where sometimes you'll see in some stats the visually loaded as a performance metric. That's when this happens, is once painting is finished. Try not to cough into the mic. During all of this time that it's doing this, it's also parallel downloading all of the CSS, all of the images, and all of the JavaScript. In Chrome, it's a maximum of 6 parallel downloads. In Firefox, I think it's 4. But you can sometimes trick that, but I'm going to tell you why not too later. So that's how the browser is going to go through everything. Any questions on the browser? Awesome. You guys are so smart. Awesome, really cool, weird, useless transitions. So what's going to happen on the server side of these things? Sorry. Now we go into the part of which I tell you what to do, now that you know how the browser is going to work. So when the browser is serving you up the DOM elements and all of the assets, you want to make sure that your server is enabling gzip. So this is just going to compress everything, just like if you zipped a file and you emailed it to your mom, but a lot much more different of a compression engine and something that you can actually unzip. You don't have to download WinZip and all that lovely stuff. Make sure you minify and concat all of your JS and CSS files, specifically your dependencies and your modules, your third-party scripts. Like if you're not serving something, if you're taking a vendor and you've done it internally, make sure that you serve up the really, really crunched down version. It's kilobytes of difference on the file system. And then once you throw it onto the server, the gzip actually does a ton more zipping of that, which makes the file really small. And then this is the hardest part to do. Serve only what you need. A lot of applications will throw a ton of things into their master sort of view. So you've got all your Google code, your Facebook code, all of your social sharing is in there, all of your JavaScripts are in there, your global.js has every single file in it, and we're like, hey, let's do this. And that worked for a while because people are like, well, it's going to cache, right? And yeah, it'll definitely cache. But when you're on a mobile, it's not caching. Mobile browsers completely throw that out the window. You've got about 400 kilobytes per file to work with. Once you exceed that, the browser just like, no, I'm not going to take it. Chrome on iOS, though, is really cool because it'll actually save that cache in a really weird way that I don't quite fully understand yet. But it can get a little bit more caching when you use Chrome instead of Safari. On Android devices, Chrome is, it's native built in, so you get a little bit more caching control, but stats have shown people are using iPhones and Safaris and tablets for mobile, and it's like, oh, but Apple, you're so far behind. Why are you going so slow? So make sure you only serve what you actually need. So I told you about the parallel downloads. The parallel downloading is once you throw everything at your browser, it's going to actually go through and start to download them even before it needs to paint them. So it's actually going to do the process of getting the object before it actually even needs to paint it. You can watch this especially happen with scripts. So it used to be, head, footer type of thing, which I'm still going to tell you to do. But the browser is becoming more and more smart as we go through trying to make our applications more and more smart. So it's going to go and pre-fetch, essentially, a lot of your assets. And it does this about 6 at a time. However, it will only do this for one domain name. So a lot of the times we would try and use domain sharding to have like 3 different image CDNs, and you would try and get it to serve 3 different image CDNs, trying to grab 6 off of each of those so that you would get 6 times 3, someone did the math, assets downloaded at once. It won't do that anymore because that also hurts mobile. So it's now just going down and it forces you into 6 downloads. Not a lot. So if you want to be performing better, you're going to have to reduce that. That's what we can do on the server side of things. I'm seeing the exact same thing as you, so I'm kind of like not too sure where my notes are. So what can we do with your HTML to make your application run better? Obviously, the first step is to tell the browser it's HTML. Because if you can tell it what it's actually getting, that's a good first step. You wouldn't believe how many times this actually is omitted. So if you don't have your document encoding, your document type, and all that kind of stuff, the browser is actually just going to be doing guesswork. So it's going to go through the entire download process of your DOM and then evaluate it, and then go and do that again with the information it actually knows it's supposed to be. So you can give yourself a very, very small performance increase by making sure you use your document encoding. It's also just general best practice, especially if you're going to serve your website in 2 languages, because you want to make sure that if you're going to serve in English and French, that you're using UTF-8, you're getting the right accent character when you actually render that in French. Otherwise, a different encoding would go way off, and all of a sudden you've got star horsehead like Etsy. So the next thing you want to do is write valid HTML. So I told you in the browser that it writes a document tree. This document tree is developed from your HTML. So when you're doing valid HTML, it's much easier for the browser to actually go in and figure out what that tree is supposed to do. Further to that, if you use semantic tags, the browser even knows faster what things are supposed to be. Because the idea of the semantic tags with HTML5 is that all of these things have a place in the browser and have a place that they're supposed to be. And eliminate tables. Who loves tables? Just Adam. So it's okay. We can all eliminate tables. We agree. Done. Served. Like I said, when you put a table in, it causes the browser to do several different repaints in order to get the table onto the screen. I don't understand why it does that. Like I know why it does that. I never understood why they did that in the first place, but the way tables were just designed way, way back when is just, whoop. I didn't do it, I swear. This wouldn't be the first time I spilled beer on myself. So eliminate tables, just like this one. If we got rid of this table, this wouldn't have been a problem. So what can we do on the CSS side of things? So very important to note about CSS when it's actually doing the asset downloading is that it's going to block the rendering process. And by rendering, I mean painting. I really should have changed the verb on that one. But it'll block the painting. So until the CSS is fully downloaded, the painting procedure will not go forward in the browser. So you're going to obviously want to make sure that your CSS file can download pretty fast. So make it the first thing to download. Put it at the top of the head. Everybody's heard this before. It's mainly just because CSS blocks. CSS gets loaded first after the DOM. Modularize your CSS. This is the way that you can go forward with just serving what's needed. We have require.js on the JavaScript side of things. On the sort of CSS side of things, you can, if you write your CSS in a modular approach, that you can have your sort of global, that is your, massive set of things that you want that are always going to be there. And then for each page, you're serving just the CSS that it needs. You're going to help yourself there. This is a big one, reducing the nesting that you do. So during the CSS OM process, the browser is reading your CSS, comparing it against the DOM, and then doing the evaluation process to try and find which CSS element matches the DOM element so that it can move on to layout. You can help the browser do that faster by using faster selectors. So ID and class are obviously the fastest selectors. ID, of course, because it's supposed to only have one of them. And the class, because it's supposed to do the same thing for multiple different things. So if the browser calculates it once that this is red, all of these other things are supposed to have red, it can do it a little bit faster. With the nesting, when you get too deep into your tree, so if you've got a very large HTML tree, we already know it's going to slow things down. That's also going to slow things down when you try and evaluate your CSS and where it's supposed to belong, because it's then going forward and traversing that entire tree to figure out where it goes. I've seen things where there's been 40 nested divs and then some content. That was not pretty. This is one that's very hard to do because everyone loves background images. But when you put an image URL inside of your CSS, you're pausing, essentially, when you reach that image, for the browser to go get that image, bring it back in, and then it continues to evaluate your CSS. Then it goes and puts that image into your DOM and redoes its sort of painting mechanism. Now, this is interesting. If you specify an IE with those little if things in your HTML, and you specify a print CSS, the browser downloads it regardless if it needs it. So it will download your print CSS even though maybe this web page isn't supposed to be printed. And the print CSS was actually only for your form page. So make sure, once again, that you only put those things where you need them, because it's going to download them regardless. Yeah. I believe so, because when it's reading the DOM, it's kind of just reading it. And the conditional comments are for IE. So IE kind of is what will evaluate whether or not it's supposed to show that or not. But the other browsers are kind of just reading it. Hopefully, it's just commented out still, and they don't download it. But I'd be still a bit hesitant about it. I would have to run some tests to be sure, though. Not 100%. But as far as from what I've seen, it downloads everything, which is not cool. So let's move on to the JavaScript side of things. So, surprise, surprise, JavaScript also blocks the rendering of your page. So at this point, you've still seen nothing on your page as a user. There's no HTML, it doesn't look pretty, and it doesn't function yet, because both CSS and JavaScript will block the rendering of your page. So make it the last thing to download. Put all your scripts in your footer. This helps this helps delay the downloading of them until they're needed, because what the script will do is download, execute, and then show the page. The reason that it's blocking the rendering is because it needs to wait for the script to execute in order to know whether or not you did DOM manipulation, so that it has to repaint. So the best thing to do is let your initial DOM become painted and then do your DOM manipulation. So you do that, of course, by in your scripts waiting for DOM ready, but also moving the scripts to the bottom of your DOM. Now, like I said, in browsers like Chrome, it's actually prefetching your CSS or your styles. So it's actually going to download them before they actually need to execute them, and then it'll execute them later. I'll show you something in Chrome that you can monitor that with. Reduce complexity of your scripts. So who's heard of cyclomatic complexity? Good, awesome. So cyclomatic complexity is essentially when you've got a function nested in a function, nested in a function, nested in a function, nested in a function, and you keep going. Checkouts are really bad for this because it's very much a promise-oriented thing. You need one thing to finish before you go on to the next thing, before you go on to the next thing, before you go on to the next thing. Luckily, we have promises now, so we can start ripping that kind of stuff out. But your cyclomatic complexity makes your browser just bog down. It has to run everything and evaluate your script, and then run all of those nested scripts. And each time those are happening, hopefully you're not manipulating the DOM, because if you're manipulating the DOM, you're adding more time to it. So reduce the complexity of your scripts, go a little bit more functional. Use the new async attribute in HTML5 on your external scripts. So especially those pesky Google scripts and Facebook scripts, even though, trick with this one, even though you grab the async snippet from Google Analytics, it's not actually an asynchronous script. You've still got to put that on there. And when you do the asynchronous script, what it's telling the browser is, hey, ignore me, do the rest of your stuff. When you're done doing your stuff, come back to me, and then we'll go from there. And of course, reduce your DOM manipulation. When your JavaScript touches your DOM, it causes the browser to repaint. Depending on how you're doing that DOM manipulation, that repainting might cause a flicker to your user, might cause jank for scrolling. It might do various different things that have been equated to the user experiencing a weird type of feeling when they're using your application. And most of that comes from using JavaScript to manipulate the DOM instead of CSS. There's more on JavaScript. It's pretty big. When you do DOM manipulation, the best approach you can do is have a class that you just assign to the DOM element that is supposed to represent its new way of looking. So instead of using jQuery to say attribute style red, have a class that you can just apply and that says red, because your browser has already evaluated all of your CSS objects and has them ready to be used. So when you do that with the JavaScript, it still causes a repaint, but the repaint can be very slightly faster because it already knows what it's doing. Instead of having to evaluate what you did it change the way I moved a bunch of things, or did it change just one thing? Cache your selectors and your data in JavaScript. Has anybody heard of requery? I heard you laugh, Sean. Requery is something that people don't realize they're doing a lot. And that's when you're using jQuery to grab a document element, and then using that $ class definition over and over and over and over again. Every time you do that, jQuery is requerying the DOM for that element. You think the browser would clue in? It hasn't yet. The new JavaScript engines are getting a lot better at realizing when you're asking for the same thing and caching it. But you can do yourself a favor and cache it yourself. So put that into a variable. Essentially, if you thought of this from a native JavaScript side of things, you would already be doing var something equals document.getElementById, the ID. And then you've cached your selector. You've only queried the DOM once for that particular element, and then you can go from there. When you're using jQuery, another thing that you can do to help with your performance is using the find attribute. A lot of the times, people will need to find something that's nested in the DOM. It's kind of costly to do that with their selector algorithm, where it's a class and then a tag and then, hover. It's much easier to use the ID or the class associated with that tag, and then use the find attribute to go through there, because it's telling them where it is that they need to look, and then just look inside of that stuff. When you use the big selector thing, it queries your entire DOM for that. Now, if you're going to do some animation with JavaScript, the best recommendation is to use absolute positioning on whatever it is you're animating. When you do the animation, once again, it's going to cause a repaint in the browser, so that's going to cause some flickering and changes. Obviously, you want something to change your animating, but it's much better for you to animate if you're using a fixed or an absolute position, because the browser already knows that that's out of the flow of the page. So when it moves, it knows it doesn't really have to look after this stuff to see what if you did change this. However, if you have something that's in your DOM that's positioned relative and most likely like a slide down, like an accordion slider, it does that, but then it repaints the rest of the page as well to make sure that it's still in the right spot. Images. Who loves images? Yeah. That's definitely here. Like, what do you mean in lazy loading your JavaScript? Like, you want to load the script lazy load, or? Yeah. So you could utilize your data attribute and read your DOM and then go through and render all your pages. But that's kind of just like cheating performance metrics because your end user is still going to have the same feeling because they might get something quicker, but then that something is changing on them. So it's kind of a toss-up of what you want to do. Do you want to make something show up faster? Like, is it a landing page that's, it's pretty okay to go with, and you can add the stuff in afterwards, or do you need that look and feel? If you work in an enterprise level, they're always going to go for the look and feel because the marketing department kind of has say over it all. But you can involve some lazy loading. I would just make sure you don't do it on anything that's crucial, which kind of goes with serving only with what you needed. So if you don't need it right now, serve it later. The industry standard for images is setting your JPEG to progressive and to at least under 60. Most manipulator tools like FC, anytime you upload a photo, that photo is set to a quality of 50. They don't care. It is set to a quality of 50. And then that's what will load on your site. Quality of 50 actually looks really good unless you look at it on your Retina screen. And it's okay. So reduce the quality of your images, but it's honestly not going to make your images look ugly. Use image sprites when possible. Not big, huge, massive sprites. You still want to make sure that you're controlling the size of these. But that does leverage a little bit of caching. The caching is a lot better with images than it is with scripts and CSS. Convert as much of your sprite images into inline SVGs. SVGs are just HTML. The browser knows what to do, and it just goes from there. And then reduce the amount of images and lazy load your images. So images are definitely something you 100% can probably get away with lazy loading if they're below your waypoint or your viewport. This is pretty common standard practice now, but be careful of the library you choose because some of them are pretty nasty and cause a lot worse performance than they should give you with a performance gain. And then utilize the responsive image spec. So this is how you can serve the image that is supposed to be there. The picture element, even though it looks like it's downloading all these different assets, when you look at the source view in Chrome, you'll see that only the actual correct one had downloaded, despite it looking like it's using one that's completely different. You can also simplify the image. So in addition to the fact that you have a ton of images on your site, the simpler they are, the faster they load. That's simply the algorithm that makes the image have a larger file size. It's a simpler image and has a smaller file size. You can do some pretty cool things to have the same physical size image to reduce its file size without losing a ton of compression and losing the things. You can apply some selective blurring to your non-focal points. You're probably going to have to get marketing involved at this point. You need an artist's eye on this. You probably don't want to do this automated because it'll probably screw it up. And marketing will be like, hey, why is this baby's face blurred out? But I mean, if you blurred out the baby's face, you probably saved about 10 kilobytes. And then, of course, properly crop the image. A lot of the times, people send these big, huge, massive 2,500 pixel hero images and use it on your hero, and then I'll go use it on your Facebook card, and then I'll go use it on your other piece of content in your sidebar, the exact same image that's massive. Serve the one that you need. Make sure it's cropped for the spot that you're using it in as well. We had an issue with that before where I had an image that was probably about this big, and it only needed to be this big. So just crop it out. This one's tricky, and I found out this one recently. Even though you think the browser is going to cache your image, probably not. You have to tell it to. So be smart. Make sure your images do have your cached headers set, especially if you upload them to S3. It's a couple of other extra clicks that you do. If you have like an uploader that does all of your assets for you, make sure that your uploaders are programmed to set your cache headers so that that image actually will be cached by the browser or by your CDN. Fun. We're almost done. Fonts also block rendering. Surprise, surprise. All these things that'll just block the page from showing something up. And it can cause some blinking. Now, this is custom web fonts, I should mention. So when you're using a custom web font, a lot of people will just get the font, throw it into their website, and use it without really understanding whether or not, do they need the French characters? Do they need all of the ligature characters? Do you need all of the numbers? Is this something that's just a title casing? Do you need all of the punctuation marks? So you can use things like Font Squirrel to actually go in, modify the font, and only give you what you're needed. So once again, just serve what's needed. Reduce the amount of font weights and font styles you use. Every time you use a font weight or a font style, if the font that you're using doesn't have that weight or style, the browser will fake it. That faking costs you performance time. It also looks really weird. If you ever fake italics on a custom web font, you get some anti-aliasing sometimes, you get some weird looking characters. So be careful of that. Turns out this is wrong, so I'm going to ignore that. But once WAF 2 is widely supported, use it. Turns out Internet Explorer decided not to support it, so it's not quite ready. Going along with the custom font and the font weight, there's some element tags that naturally tell the browser to render this visually different. Those are B, I, M, U, strong, and all of the H tags. These will tell the browser to use, by default, different weights and different styles for your font. If you're using a custom web font and you're going to use these particular things, make sure that you override the browser default or that you have the right font weight for that particular thing. Otherwise, you're causing some performance and you're causing some weird visual things to happen. Colors. Surprisingly enough, every time the browser encounters a hex code for a color, it actually has to go figure out what that is. And it doesn't cache that in any way. So if you can reduce the amount of colors, you're going to reduce the amount of calls you're going away. That's like really, really minute, but if you want to try and squeeze that little extra lemon juice out of there, you can try and reduce your colors. Probably also going to help out your big team if you have a giant team and you have 50 shades of gray. Which shade am I supposed to use? And I actually had that when I worked on Walmart. We counted and we had 50 shades of gray. We reduced it to, I think, 10, which is still a lot. Properly nesting your HTML elements that involve color. So if this goes back to the DOM tree. When you have something that's a paragraph tag down here, and it's supposed to have a color of red, make sure that that is specific to where it's supposed to be. And then make sure you're setting your colors for the rest of your website as high up as possible so that your browser isn't constantly going back and forth during the layout and rendering phase to know, is this the correct color that I'm using? So if you take advantage of nesting of your CSS so that the colors cascade correctly and you only change what's needed, you're helping yourself out. Other things for performance. I like this next one. I hope you do too. Carousels are evil. Does anybody agree? Carousels are where you click through and it continually loads content and keeps going around and around in a circle. They really promote loading too much content. And as we said many times, we want to reduce what you actually need to serve. They honestly have horrible UX. Everyone's written their own custom version of someone else's custom plugin. I think I know 12 different versions of jQuery Slider. It's a little bit crazy. And they actually really perform really badly because they're in line. So every time you press that next button, you're causing your browser to repaint. Press that next button. You're causing your browser to repaint. You want to reduce how many times your browser has to do all the calculations to make your website look pretty. The other thing you want to take a look at is doing some A/B testing. Doing your A/B testing will lead you into understanding what your users actually are using and aren't using. So if you have a big, massive hero image, and marketing is adamant that you need that, but you think you don't, test it. Prove them. There's been a lot of cases where a big, giant hero image didn't perform at all. I think we got rid of them once on a different project I worked on and replaced them with 4 different small marketing components, and that actually increased our conversion a lot more than having one massive component. So test it. See what makes you more money. So I did want to show you just a couple things in Chrome. That just a couple weird features I stumbled upon. I will use our website. Why not? What is our website? So can you guys see this okay? It seems kind of tiny. Oh, too big. So your DevTools is probably set up however you've had it set up. So do whatever you need to do to bring up the little under sidebar that comes up with the console. So when you have the inline console, not the console tab. Hit emulation. And so this is where you can obviously, you already know that you can go through and set your particular device and such. I actually don't want to use a device right now, so it doesn't matter. And in here, very difficult to do this on a giant screen. This is where you can, this is a little thing that I found a little bit cool. This is where you can look at where your styles are coming in and being used based off of your different CSS media queries. And then, of course, when you are doing this, you can do touch instead, which is cool. Let me undo all these because it's not actually the core thing I want to show you. And those are in the emulation part. In the rendering part, does anybody have epilepsy before I do this? Okay, good. Do not do this if you have epilepsy. So enabling paint flashing is going to give you a visual cue for every time the browser is renegotiating where something is going to be. It happens a lot more than you think. And I'm also going to show my frames per second. So I'm going to reload this page here, and you're just going to watch how much green flashes up. I actually don't need the emulation anymore. So every time you see the green flash, that's when it's renegotiating where to put something. This is a carousel. When you saw that carousel loaded, for some reason, something that was already on the page all the way up here, there we go. We're going to reevaluate the entire top of the page that I've already painted because of bloody carousel. Let's click on the carousel. Away we go. Oh, luckily this one is actually using absolute positioning because I fixed that already. It also shows you when you're scrolling, which is cool. But this is pretty cool. So if you have any painting that's going on when your mouse is going over, take a look into your JavaScript and your event listeners and be a bit more careful about how you use mouse touches. Because if you're going to end up painting while you're moving your mouse, causing a lot of end user performance differences. That one's not particularly a loading thing. It's more of like how your user feels about your site. And then we have our frames per second here. Your computer should pretty much be up to 60. I don't think I can make that one any bigger, unfortunately. This is more so for when you're animating. If you're going to use JavaScript animations, be careful what library you choose and which ones you use, because this, if it drops down, oh, there we go, 26 seconds when it loaded that carousel. Do you see that? or frames per second. Let me do that one again. Watch this number, 60, 60, 60, carousel loaded, 30, 20, 29, 50, back up. So let's say that carousel is further down on your page and you're browsing the website here. It's still going to load because the browser is still going to load. And all of a sudden you're like, not so great. So I just wanted to show you that cool little feature. You only want to have it on when you need it because it's really annoying if you forget to turn it off. I mentioned some tools, obviously Chrome DevTools. Webpagetest.org is what I use as our baseline. Every time we do a deployment, I go and I run a test on there. We also run an automated version of it, but I do mine during about a peak time. And I go through and I compare how our site is loading. This link, and I'll share these slides so you can click on these things, is just on how you can reduce the file size of your custom web font, because they can be huge. State of Web Type is going to tell you about how you can use your fonts in a better way. And then there's a nice library for lazy loading. Questions? How well these compare to other things that we've done? Not so much. These are kind of just sort of best practices that I have put into our systems here. There are benchmark stats out there for these things, especially when it comes to JavaScript performance. There's an entire site dedicated to it, JSPerf. And a lot of the JavaScript stuff does come from there. And other performance benchmarks you can find from the Baymard Institute, B-A-Y-M-A-R-D. They do a ton of stuff for e-commerce related sites, and they'll show you different statistics and stuff on that too. No, but they sound cool. They sound like they'll solve a lot of caching problems, domain sharding problems, and SSL problems that hurt performance. So those should hopefully help. Yeah, so that would go back to sort of serving what's needed. So if you have a baseline page and you only have what you do need for your critical stuff there, and you can serve that up faster, go right ahead and then augment it with your DOM manipulation afterwards. But be careful of when your user starts to interact with your page. Because if they're starting to interact with your page and you're not actually finished loading the extra stuff because you kind of fake loaded a lot of things, you want to make sure that you don't compromise your experience. You want to get a hold of me? That's me. And then you wanted to quick break and then your talk, or do you want to just go right into it? What do you feel like? Oh, I also had a question earlier. How many of you work in the area? No wonder. See, we always had meetups at the King and Spadina area because there's so many tech businesses over there. But there's also a ton over here, too. So it's like, how many people are going to show up to Liberty Village? So that's good to know. Most of you didn't have to go way out of your way. Okay, so let's take just a little 5-minute break while we switch all of this stuff over and talk amongst yourselves. And reset the size of my screen. That'd be so annoying. Okay, good. Carousels and carousels. The people who didn't want to hear me are here.
I'm good, man. All right. Check one. Oh, I broke something.
What did you do?
I don't know.
You can't be on my spaceship. You broke it.
There.
You're just gonna have to dangle it.
There you go. I don't know if that's how it works, but it's how it works now. Check one. Check, check. Okay. All right, everyone. So, hi, friends. I'm Brian. I'm one of the achievers, and I'm going to talk to you about something that is not that awesome ASCII art weather application that you can get for your command line. It's something else. So I'm going to tell you a little bit about how I kind of came to this as a philosophy. And if you think about it, a lot of what James just talked about was how do I make my applications more performant for the front end. This is more about how do I become more performant as a developer and get things done really quickly and not repeat myself. But it's not necessarily about the lines of code. It's more about starting off on the right foot and all those things that you do when you do your day-to-day stuff. So it's kind of an archaic term, a skeleton project. And the reason is it's been around forever, and other people have rediscovered this because it feels like such an intuitive idea. So this isn't like a super complicated topic by any means, but it can lead to really great things you can do. And it goes by a lot of names, so I'm just going to take you for a moment to think about your day-to-day development if you're a developer. I'm just starting a timer here. So if you're a developer and you're starting off on a new project, give me a language or a framework that somebody's using. React. So you're going to start your new project, and it's going to be in React, and you're going to have a whole certain set of things that React lets you do, but then you're going to be narrowed down by a certain set of things that you actually are going to do in your business. And sometimes if you're just starting off on that project, you might not know what they are until you get further down the road. But the interesting thing is other people might have already found out what those things are. So what does that look like? You start, so this isn't React, but it is a Node.js kind of repo. So you start your project, you install your framework of whatever it's going to be, you build something, and then you install your test suite. Like, okay, I built it, now I have to test it. And then you say, okay, well, my code wasn't really testable, so I have to go back and fix that. Then you're like, okay, now I have to deploy it somehow. It turns out the way I wrote that thing doesn't work in my deployment, so I have to go back and change that. And then you have to go and write the build scripts to actually ship that to production. And then you found out, oh, there was a problem in the way my thing built itself because it built it incorrectly, like maybe the way I'm doing fingerprinting of my assets don't work correctly. So you go back and you fix that. And you're like, okay, but I talked to this database. Now I talk to this database, and the database says you need to do a certain connection to a certain protocol, like let's say MySQL or something. Then you go back and add a feature, like, okay, code quality is getting out of control. We need to go back and add some stuff in there to take care of that. Then you're like, okay, the way I've organized all my files and file names and paths are just, it doesn't scale anymore for my project. So I'm going to have to rename everything and move all the files, and I see some nodding heads. We've totally all been there. And it's kind of crazy. And you feel like this guy, and you're just like, okay, I'm going to mop up, and I got some more over there. And it's really annoying, right? Like, everybody's been here at some point, I'm sure. So what I'm talking about is it talks a lot about, like, don't repeat yourself, but it's also more about how to avoid this problem. And to me, it's great for, like, don't repeat yourself. I think it's a great way to set off on the right foot and not track mud through your mop. So wouldn't it be nice if you start off with a project that did everything the way you wanted to? Because if you think back, all of those design opinions, I'm going to use a specific test suite. I'm going to deploy a specific way. I use a specific database. React or whatever you're using might not know about those, but you know about those things. And there's no reason you can't set up a skeleton project that's aware of all those things right off from the get-go. And what that means is when you start writing code that way, you don't have to go back and sweep up your old footsteps to make it work moving forward because you've already chosen that going forward. All you've really done is closed in your design opinions a little bit more up front and said, this is my design opinion, this is how I'm going to do it, instead of the other way, which was, oh, I've run into a problem, I have to kind of clean it up. But the other really interesting thing about using these skeleton projects is you can actually inherit other people's design opinions. Now, there's a challenge there, of course, that you have to inherit their opinions. And maybe it doesn't work for you, maybe it does, but there's also ways around that, and I'll get into that. So, unfortunately, so far at this stage in the presentation, I've said, okay, you had a problem, just draw some circles, and then there's your out. So how do you actually fill in the rest of this, right? So the rest of this presentation, I'm going to kind of take you on a tour of certain things that aren't skeleton projects, but help you understand some of the same goals, so it helps you do some of the same stuff, and kind of understand what's the differentiating factor, how to go beyond the skeleton project, and how to actually do the, the infinite number of steps in between draw some circles, draw an out. Questions about any of that before I move on? So, has anybody heard of any of these terms? Other than skeleton projects, I just said it. Okay, I got a few hands. So here's the secret. All of these are pretty much talking about the same thing, except for scaffolding for some reason. Almost everywhere I go, scaffolding is specifically talking about code generators, and these seeds, foundations, bootstraps, and skeletons are all like, here's a starter project that you build and grow off of. So I'm going to take you a little tour of some scaffolding first. So I got 4 projects up there. I'm sure you've heard of Ruby. Has anyone heard of Ionic? Few hands. Yeoman? Awesome. And Symfony generators. Awesome. So if we look at this stuff, I actually have a console open here, and I don't have Ruby installed because for whatever reason it just didn't install correctly. Okay, so scaffolding. So Yeoman's this awesome scaffolding tool, and what it does is it's an open source project. Everything I show you is open source, so that goes without saying. And it's designed to help you scaffold projects. So all I did is say yo, and it says, so I've pre-installed Yeoman and I've pre-installed a generator for you just so you can see it. It's like, okay, I can, generate a web app, do some other stuff. So I'm going to generate a web app, and it's going to do that for me, and I'm going to say, yeah, I want Sass. So, those, I get to bake in some design opinions of like, I'm going to use Sass. That's an opinion of mine of how I want to build stuff. Maybe you want to use less. I don't know. So it's going to do a bunch of downloading. And when it's done, it's going to generate a skeleton. It's not so much a skeleton. It generated a bunch of code for me based on what it thinks you need for your design opinions about a typical web app that uses Sass. And I'm going to kill this because it's going to take forever. So, and it's a really kind of like cutesy program. It's a lot of fun. And the really interesting thing about Yeoman is like it has generators for pretty much everything. You have a PHP project, I'm guarantee you there's at least 6 right away, minimum, just for PHP, and I don't mean a PHP framework, I mean PHP. Node, Java I've seen in there. I said OAuth, and I have like a .NET generator, which is crazy in my world because I'm not a .NET guy. So I was impressed to see an NPM package that helps me create an ASP.NET project. Like, it was weird. So it's really cool, and it works for everything. Not a skeleton, but it's scaffolding, helps you build stuff. So has anyone seen that before or have any questions about that before I show you another cool thing? Cool. And if you think of something in the middle of this, just shout out. So I'm going to show you an awesome one called Symfony. So there's a really cool project by Symfony that generates basically, you can generate all kinds of cool stuff. So I'm going to go into, there's actually Symfony itself has a generator, and you just say like Symfony, new, and like I'm going to call it a blog, for instance. And it's going to be like, oh, you want a new blog, huh? Well, we'll just download the whole framework and set it up for you and bootstrap it all together. And so I'm going to show you that directory. So there's, my whole product, and I can actually go in. So that was a thing that helps you install Symfony projects. But inside Symfony, I have console. I have a whole bunch of other cool things that help me generate things. So in Symfony, if you have like a region of code that does a thing, like a domain of business logic, you can call that a bundle. And so I'm going to do generate a bundle. So it interactively asks you stuff, and I'm just going to like foo bundle. Yep. So let's go to foo bundle. So everything in here was generated for me automatically. That includes my controllers. So if you're from the Rails world, you can generate Rails controller, if you've seen that before. And you can see it go into controller, and there's my controller. But it actually gets cooler than that, and I want to show off one of the cool features here. Typically, as web developers, we have like one thing that's bare minimum expectation of us. We can make a CRUD form, like you insert the data, you get it back, you edit the data, you save it, you list it out. And so you can actually do the PHP, I'm just going to clear that so you guys can actually see what I type, I'm sorry. Generate, and so what generators do I have? Where am I? Oh, my mistake. I'm going to generate a CRUD. What did I do wrong? Doctrine CRUD. Thank you, friends. So I'm going to say it's Acme blog bundle post. Right, I had to generate the entity. Okay, so I'm basically going to save that, and I'm going to say it generates the full website end-to-end, the database model, everything you need. It generates all of the skeleton code that you would want to then take and turn into something more interesting than what it is. So just for the sake of time, I'm going to move on to the next thing. So that's a really interesting way that you can just leverage some stuff. And I also have one more in Ionic. So for anyone who's played Ionic, I'm going to show you. You can basically say Ionic start and say I'm going to call the app a my app project, and it has a series of, so Ionic is a project that is designed to help you use HTML5 to make web apps. So whether or not you think that's performant, okay, this is what the project does, and it has a whole bunch of default layouts. And chances are with the way web design is and mobile design is, you usually only have a few types of app layouts that you really want, right? So this one's going to be tabs, and it's going to download it, it's going to install it, and I can actually say, okay, Ionic launch, and right out of the bat, I will have the ability to build an Ionic app with that layout for me. So all that cool stuff's going to happen. I didn't install Cordova. Was there a question? Or? Okay. So all those things are amazing, right? Like they save you tons of time, because if you don't do that, you go back to, git init, add project, add thing, add Cordova, add the Angular, add this thing. So all those things are cool, granted. But they're not skeletons, right? They're all generators that generate stuff for you. And they do ship some opinions about how to organize stuff, but it's hard for you to do something interesting with them. And what's interesting about it is it's a whole extra barrier of you taking your design opinions of whatever projects you build and then making that reusable and reusing it again and again. Because now, it's a generator. You have to actually write the code to generate the code. And maybe you even think, if I have code generating code, maybe that's like a compile time step and this should be metaprogramming. You go down a black hole and you have to really be strict about when you get out. And I don't know about you, but a lot of generated code I've seen isn't actually that great because it wasn't written by a programmer, and we don't give our generators the brains to say, oh, you're just doing duplicate code, right? Because that's all the generators do. So I want to show you some cool skeletons that I found. So you can look around, and the only really popular one that I've seen is the Angular seed project. Has anybody in this room written an Angular project in the past? Cool. So I got a few hands. The Angular projects can get really interesting, and they can grow very gnarly, and luckily they've given a project called Angular Seed. So, okay. So in the Angular Seed project, I just have the basic stuff bootstrapped for me that I have directory structure opinions, and there's a bit of stuff that ties it together. So if I go into my app.js, it ties some of that together for me. And it's like, oh, okay, I have at least 2 views and some stuff that I can put together. And I can build on that very quickly without having to think about how I'm going to invent it from scratch. The downside is maybe it doesn't work perfectly for my case, but I can also say, oh, this thing uses Bower. I don't want to use Bower ever, so I just remove Bower and say, okay, so that's my new skeleton for me personally. It's like, great, there I go. And I can take that seed and I can say, this is the seed project I'm going to use for all of my projects. Very small scale example. So here's a really neat one that I found for Node.js. And I say really neat, and I didn't find these other 2 by searching Google. I actually went on IRC chat rooms and I asked people, I'm like, hey, does anybody on here have a skeleton project you use when you start off on stuff? And it's amazing the kinds of stuff you find. This one actually blew my mind because this guy has actually gone in and he's said, maybe this isn't the right stuff for everyone, but here's what I have. And right out of the bat, if you start at the top of this, you can write in the latest version of JavaScript and compile it down to the version that works in your browser. And it does very opinionated unit testing using Chai. Other people want to use other things. He uses ESLint instead of Crockford's lint or JS hint. He uses gulp instead of grunt. He uses handlebars for templates. He's got less in there. But all of these opinions, and Webpack instead of, let's say require or something like that, all of these opinions is something that he's shipping as a product that I can say, wow, everything is here for me. I just go in package.json, it's there. And not only that, I also have an awesome gulp file where he's already put together everything for me. I'm like, wow, I can just say, build my project, and it assumes all those things are done for me. So I don't have to say, I really want to use that latest JavaScript. How does Babel work? Somebody solved that problem for me. And not only they solved that, they solved all these things. So I just download this project, and I say, okay, great. So I'll go into my source, and I'll go into main, because it's very clear what directories are for what at this stage. And I just say, great, I'm going to open index.html and I'll say main.es6, which is going to get compiled to regular JavaScript. And everything that I want, it's already identified for me, but it's not auto-generated. And let's say my opinions change from his, I can then again just take it and say this is my foundational project. So I can do all that stuff, and that's really cool to me. So questions about that? So I want to show you one more in PHP. Is anybody familiar with PHP and Composer and things like that? Okay, so we got a few people. Awesome. So somebody else wrote this awesome PHP project. Now, it's not a framework. It's actually, they just took stuff that exists in the modern PHP ecosystem, like Composer, which is a great package manager and things like that, and PHP Unit and great mocking libraries and I actually have never used Fake, but it's, it's kind of cool to test. SQLite 3 and stuff like that, and Selenium for your automation tests. And basically, everything you need to do is already available for you, and you can just say, great, I'm just going to build this, and it even has a build file for you to tie into your continuous integration. So I don't have to figure out down the road how my continuous integration is going to work. I just inherit this person's opinions about how it works, which is great, because I don't have to re-solve the problem. Cool. So there's 3 really cool skeleton projects. And so this is just, somebody else's opinion. And I know, like, we're programmers. We're super opinionated and passionate about the tools that we use, right? Like, why would I ever use Mocha? Oh, my God. There's, like, okay, you know what I mean, though, of course. So you can use any tools you want. You can change things. And so I'm going to take this into a different direction. I'm going to say that part where it says, okay, there's the circle, there's the owl. Let's start exploring that space between that. And so that was examples of stuff that exists, so let's try to break it apart a little bit. Those of you who love your APIs, has anybody ever had to author your own SDK for an API or play with one before? Okay, so very briefly, an API, you're very familiar with what that is. You just have an endpoint somewhere and you request it. Let's say it's a web API. You just request a resource from it and you get it back. The SDK is the tools that the vendor of the API provides to a developer and says, here's a whole built-up set of stuff. All you have to do in your code is call something very deliberately, like Amazon, save this in my S3 bucket. And under the hood, the SDK that Amazon gave you will figure out all the calls to make, all the ways to encode the data. And myself as a developer, I don't have to deal with it. So this is kind of a case study of, I'm just going to show you 3 different API SDKs, and then we can look at maybe what are some design opinions to understand why are they all different, because the design opinions of how these 3 things work are completely different, even though they all basically just call an API endpoint, and they save stuff. Like, that's all it does. So I'm going to show you that stuff. So Amazon Web Services SDK in PHP. They have, you want to see something cool, is just the sheer amount of stuff. All of these folders are basically like one of the Amazon services, and they just dump it into this folder of everything. And it's mind-blowing, all the stuff they have. So I'm just going to go into EC2. So they have this EC2 client. And so how does this work, right? So they have, well, there's going to be a lot of that, so let's just jump down. Great. So it's mostly common. So they have a client. They say, okay, great. Give me my endpoint provider, and we're just going to call the parent and construct that. And our parent is the AWS client. So the AWS client will look at like a manifest of endpoints and try and figure it out. Then it's like, oh, I need a client resolver. I'm going to find that. Then it's like, okay, give me the URL. Then I'm going to try and use this web request driver called Guzzle. Like, you can see you start to get the feel for what the design opinion of the author of this code base had, which is everything is going to be completely, fragmented into its own thing, so nothing breaks everything else. And it's all going to kind of depend on this central nugget of how we do requests, and everything kind of depends on that. So that's Amazon's API SDK. I'm going to show you, everybody's heard of Stripe, the PayPal competitor? So let's look at Stripe. Theirs is fun fact, if you ever go into a project and see lib, chances are like it's definitely a C or C++ shop. Like that's just what they do. So I'm inside the lib directory, although there's nothing wrong with doing that. It's just like, you know, and it's an opinion inherited from that time. So cool. In here, we have a very different structure, and we're just talking about all these objects. But the main thing, the way Stripe's thing works, is if we go in here, oops, sorry, Stripe object, and was that one? No, it was create. No. Basically, the way this one works, where did they hide it? All of the API objects basically take a request, like you give it an object and you say, okay, I want to create something. Why can't I find that? Oh, sorry, API resource or requester. That's what it was. And they call the API base. Sorry, I don't go into this thing very often. But basically, they say, okay, you know, the request is going to be handled by this thing, and I'm going to give you an API response, and I'm going to do a request raw. So the request raw basically takes your object and does a whole bunch of stuff to it to figure out how to reform it for whatever purpose it needs to be. So the maybe it'd be more helpful if I just showed you the README, because that one shows you how they expect you to write your requests. Basically, you just go in here and you say, create a charge, and based on the way Stripe's API works, their SDK says, oh, you created a charge, you must want me to make a web request, and it does that. The design opinion is, of course, you know, different from Amazon. It's like you were being very deliberate in pushing stuff out. So that's two different design opinions. They look very different. I'm going to show you a third one just to show you. The third one is how I wrote an API SDK for something, and it's very different. Basically, I have a client, and I have a rendered template request factory. And basically, in my client, I have, you know, give me, I say, give me a template of some sort, and that will go off and create a request object. And the request object is then created, which is a representation of a web request. It's not an actual request. And then I send that request out, which gives me a response. I get the response back, and I get the content, and I return it to something. And this is basically just rendering what that request looks like in the body of the request and all that stuff. Three very different design opinions. So I'm going to show you a design opinion, and this is an exercise interactively. So here's a design opinion. I have an object, which is, let's say it represents a user or some kind of data entity or DTO or whatever you'd like to call it. And I want to then take that object and give it a transformation to something like XML or JSON or whatever you would like. I'm going to send that out as a web request to some endpoint. That will then come back as a response. My API SDK will manage that response. You know, if I got a 500 status code, I should throw an exception. How do I do with that? The opinions are baked in there. I then parse the XML and say, okay, that's the user XML I got back. I'm going to create an actual object in my code based on it and return that back to the person who asked for it. Or, sorry, not the person, the thing that called for it. Sometimes I refer to my code as people, I'm sorry. So where, interactively, like just shout out, where do you think the design opinions of this work? And where do you think the business of that being a user, where does that live? XML? Definitely. XML is a design opinion I imposed. It could be JSON. Why not just serialize it as binary? Why not do something else? That's my opinion. the fact that I'm using HTTP, the fact that I'm passing in, a correct object. All of these things are my opinion. The fact that I'm managing responses at this stage and not somewhere else. These are all my opinions. Where does the business logic live? So the business logic would live in what the objects I'm actually sending out are, what endpoints are they hitting, and what do I transform them back into? Like, what's the actual resultant XML format? So yes, I'm going to use XML, but what's the format going to be like? Is it, am I giving back all the information about the user? Is it partial information? It has to fetch more. That can be business stuff. So if you look at it that way, and you break it out that way, you can say, if I take my design opinions and I make a foundational API SDK, I can now be incredibly productive and bring those 3 design opinions out to 3 different projects. So the business becomes the implementation of my skeleton project, and my foundational API SDK is what I do. So if I wanted to look at that project, I would only really need a few basic classes. Base. I would have a web client that manages the request, a request factory that builds the request and hands it out, and some kind of transformer that would take the XML, turn it into an object, take the object, turn it into an XML, pass it back and forth. Those are the foundational things I need, and then when I go to implement it, I build on those. What's really interesting is where do you now draw the line between what that is and what, might be a library or a framework even. So thinking about this, I've given you a whole bunch of different examples of things that are skeletons, things that are generators, how you can break things apart and take your design opinions and ship those as a product and then implement the business layers on top of that. What else can you skeletonize? Does anybody have any ideas or suggestions? Because I have a whole bunch in the next slide. So if you'd like to shout any out. OAuth. Yeah, you could actually skeletonize that. In fact, OAuth's like a solved problem of domain too, so you can just directly inherit that thing. You probably don't even have to change much other than the config. Cool. Microservices. So you have a very tiny NPM repo or something in Node.js that all of the stuff your microservice is built on, like guaranteed 100% of the time you're going to use Postgres in this. Whatever company, like a fictitious company, you're going to have a certain set of infrastructure, and let's say it's Postgres. Let's say you run a certain set of tests. Let's say you use a certain testing foundation. Let's say you use all these very specific things. You can just make that seed project and roll it out. You could also take a framework. So I showed you the Symfony framework. Something I've done in the past is I've actually taken that project and I said, not only is that the Symfony foundational project, I'm going to take that and say, well, I myself know that I always use PHP Unit for my tests. I always use this for my tests. I always have OAuth actually in every project that I use. So I made my own skeleton project that I would then use for every other project that I spun up. And it's just like, your time is saved and you don't have to waste your time going back and forth. You also have similar libraries. So those SDKs, so I actually kind of showed you that, so I'm not going to spend too much time talking about that. Really interesting idea is you can take this and you can actually do the same skeleton idea for virtual machines, right? And there's lots of ways you can do that. So if anyone's kind of on the IT side of, sysadmin, you can do this with Vagrant. And one really cool PHP project called Laravel has done this. They've made a cool project called Homestead. And Homestead says, I guarantee you these very specific design opinions. You're going to use that database. You're going to, sorry, my timer died. You're going to use that database. You're going to use all these specific things. You're going to get them every single time. You're going to load it in the specific way. But everything's going to work for you. You can hit the ground running day 0. You can just use it. and it's awesome. You could also look at it another way. So if any of you have played with Chef, it's a really cool tool for providing, you can use it for a lot of things. One thing you can do is say, okay, I want to create a server in a very specific way. So you actually have a manifest file of like, these are all the things the server should have when it's done. You can take that as a manifest file and say, great, I have it. I'm going to take that over here. I'm going to change the things, and I'm going to make my own skeleton server every time. And then you can use that as your base for other servers you want to build out. Because let's say your design opinions at your company are, we're going to use CentOS 7 everywhere. We're going to use LDAP everywhere. We're going to use all these IT-specific things, which I'm not going to go too much into, everywhere. TPS reports, like think about it. You're already doing this probably for your day-to-day reporting if you have to fill out a JIRA or something. You know, it's all kind of there for you. Any other ideas or things like that before I go on? Cool. So you have a skeleton, and it poke evolves into something else. And what's the natural progression if you do this? If you take all of your design opinions and you take out all of your business implementation, you say, I'm going to isolate it. What's the natural outcome of this? And it's happened before, and it's happened for some really cool projects, and I promise you almost everyone in this room, if you're a developer, you've probably used one of them. Laravel Homestead, I've already mentioned that. Zurb Foundation is a CSS and HTML5 like layout framework. And basically, here's the origin story of it. There's a company called Zurb, and they were a design agency. So it's we need a website. You're gonna pay me. I'm gonna build it. Okay, you need a website, and they get everybody, you know. But they needed to be very efficient at it because, you know, you're not going to start from the scratch on everyone. Say, okay, guys, let's make a foundational project. And they did that, and it was great. And then they said, we're onto something here. Let's open source it. And now they're on like version 4 of Zurb Foundation, and it's a massive open source project used by tons of people. Very similar story for Twitter Bootstrap. Twitter Bootstrap is basically the same thing. Twitter said, we use this bootstrapping project for all of our web layouts. Let's open source that. And who in this room has used Bootstrap at least once? Right. You're just inheriting the design opinions of Bootstrap. But that's gotten to a place where you no longer have a Bootstrap, you know, grid layout. You have a whole framework of stuff. But you don't have the business. You just have the opinions of how it works. And maybe you don't like those opinions. But, you know, you have something very cool for it. And I said skeleton is one of those old term things. Anybody in here use a Unix, a Linux, a FreeBSD, a Solaris, one of those things? Yeah. Take a look on your computer at /etc/skell, not on your Mac because Mac doesn't do it. When you create a new user account on many of these systems, not all of them because like all these systems do different things, it actually copies like .bash profile from that directory, and then you can add on to it. Like this stuff's been around. It's in all kinds of places. So take your design opinions, isolate them from your business implementations, reuse them at least for yourself, and release them to the world because you have great opinions, I'm sure. Just make them nice and robust and reliable, and other people will take them, and you might be onto something amazing that is useful for a lot of people. And this stuff isn't like, okay, I'm going to reinvent like some super complicated framework. You can start very small. Like this isn't the most complicated stuff, but it's super valuable. So everybody in this room can probably take your design opinions, say, I'm going to make my own skeleton project, at least for myself. As other people like it, they can use it. It's going to help them. You can go wild on that stuff. And then you end up in this situation again, just like, that's my opinions on like how to make software. Cool. Question round. Question is, doesn't Yeoman give you access to a bunch of skeleton projects? Yes. It does a lot of really cool stuff. I encourage you to check out Yeoman. Yeah. Other questions? For myself, this repo here for skeleton, Web template? Yeah. Git remote dash v. This guy's template, SUB, I found him on the Stack Overflow JavaScript chat room, and he's like, yeah, I have this cool project. I think it's awesome. Check it out. And there's only like 4 people that know about it, so well, a little bit more now, but yeah. And there's tons of stuff out there, so go nuts. I think it's cool. Would I differentiate between skeletons and frameworks? Yes, and I think skeletons are what frameworks were. Like, well, skeletons can grow into frameworks, but it's not a micro framework. Sorry, I didn't hear that. So the RESTful API stuff. So if you think about the RESTful API, that is a design opinion of yourself. So you're saying I want to use REST over SOAP or something like that. So you can actually use a library that does REST, or you can say my API SDK is going to use REST. So if I go into skeleton, oh, sorry, my mistake, SDK. So if I go into here, like I can enforce REST as part of how I build my request objects. Because remember, a design opinion of my thing was I build a request and I send it out with my client. I can enforce that here. Sorry, that's really weird. This is actually a hackathon project, which is why I have that weird thing going on. But I can basically enforce all of that in the thing where I build my request objects. And if you want, there's other projects out there that you can inherit those design opinions from. Okay, anything else?
Thanks, Ryan.